All right, welcome to day 2 of the math ACT prep class. A couple things real quick, just some tips before the test. Make sure that you are staying hydrated. All right, now you got to be careful there. You don't want to drink a bunch of water right before the test and walk in and have to use the restroom, but you want to be hydrated before you get there. So make sure that you are drinking lots of water the day before, maybe 2 days before. Staying hydrated. Second thing, you want to make sure you get a good night's rest. All right, you don't want to go in tired, groggy. You want to make sure you get some good rest. If you drink coffee in the morning, go for it. If not, don't worry about it. One thing you want to make sure you do is eat some breakfast. Okay, you got to have some food in your stomach to sort of let your brain work at its best. So stay hydrated the day before, at least. Maybe drink a little water in the morning, but just not a whole lot. Make sure you get some rest and eat some food. All right, so during the test, really obvious things you've probably heard a million times, but it's always just a good reminder, is if you get stuck on a problem, okay, you don't want to sit there and try and work a problem and just spend all your time trying to figure out a problem you may not get, okay? So if you get stuck, you want to move on, all right? Move on to the next problem, all right? Now you have two options here. You can decide to either go ahead and guess at that point, and then maybe notate on your workbook that you were guessing on that problem, that you should go back and try to look at that. Or you can save all the guessing for the end. Some people prefer to just leave it blank and move on. The only problem is you want to make sure that you do not leave any questions. That's the one thing you can't do, is don't leave anything blank. Don't leave any questions unanswered. All right, don't leave anything blank. That's the number one rule. There's no penalty for guessing, so you've got to make sure every single bubble is filled in on that test. Even if it's a guess, or if you really did work it, you got to make sure every bubble is filled in. Second thing is to make sure that you don't run out of time and leave problems that you could have successfully answered at the end. In other words, let's say the last 5 problems, 55 through 60, you would have known how to do, but you don't get to those problems because you ran out of time. That's something you got to really try to avoid. So the point is, you got to skip, right? If you're stuck, move on to the next problem, because there might be problems at the end that you know how to do, and you don't want to guess on those. You want to make sure you've answered every question that you know how to do. So the second thing is, if don't leave easy questions. That's the point, okay? Don't leave any easy questions to guessing. Make sure that you get those taken care of. All right. Moving on. One quick thing about today's lesson. Today's lesson is all about testing strategies. Okay, this is not necessarily the first choice you should always go to. In some cases, these testing strategies are the best way to do it. In some cases, they're not. But in most cases, the best way to attack these problems is to do the problems the way you're supposed to do them. In other words, work them out. Okay, these testing strategies are really, really good, and they definitely work, and you've got to practice them, but this is not necessarily the fastest way to do it. So just remember that when we're doing this. All right, so here's the first strategy. This is the big one, all right? This is one you probably are familiar with. It's the guess and check method, okay? This works really well with equations, right? And anytime you're finding solutions. So when you're solving an equation, this can be a really good method. And when you're finding a solution, this is a good method. So let's look at an example, all right? So we're trying to find a solution. So which of the following is a solution to this equation right here? All right, now we've got our choices, A, B, C, D, and E, and here are our choices, 0, 1, 2, 4, and 7. So we're just guessing and checking. We're gonna pick a number and we're gonna plug it in, right? First things first, we might try to just go down the line. So we might try 0. Okay, we plug in 0. What do we get? We get 0 squared minus 3x, or excuse me, 3 times 0 divided by 0. First of all, we can never divide by 0. Okay, so that immediately tells me that that answer choice is not possible. It cannot be choice A. Okay, secondly, let's try B, right? We plug in B, we get 1 squared minus 3 times 1 divided by 1. Now remember, you can type that in your calculator. If you're not super comfortable with these basic operations, you can always plug this in your calculator. But what does that simplify to be? It simplifies to be 1 minus 3, which is -2, divided by 1. Okay, now remember, that's the left side of this equation here. That's this side right here. Does it equal the right side? Does the left side equal the right side? Remember, that's what we said a solution is, a number that makes the equation true. So -2, right, over here, -2 does not equal 1. So that means it's not a solution, okay? All right, so now we're going to try the next answer choice. So we've already eliminated choices A and B. We move on to choice C. We plug in 2. All right, so we try it. 2 squared minus 3 times 2 divided by 2. Does that equal 1? Well, 2 squared is 4. 4 minus 6 is -2. When I divide that by 2, I get -1. So that means it's not our answer. So it's not 2. All right, so we're on to D. Okay, this guess and check strategy is clearly not becoming the fastest. There might have been a faster way to do that, but that's okay. We're just focusing on the strategy. All right, so now we try 4. So 4 squared minus 3 times 4 divided by 4, does that equal 1? 4 squared is 16 minus, right, we've got our minus sign here, 12, which is 3 times 4 divided by 4. You're going to see pretty quickly that, yeah, 16 minus 12 divided by 4 is 1, and 1 is equal to 1. So that means D is our solution. Okay, that strategy of guess and check worked just fine. It helped us find the solution. Okay, let's try another example here. All right. All right, next example. Which is the solution to the system? So now we've got a system. If you remember, a system is a little bit different, but it's sort of similar at the same time. A system involves 2 equations, okay? So we're trying to find the solution to the system. And here's our answer choices. 0, -2, we got 2, 0, -2, 1, and 2, 2. I'll just leave this as 4 choices. There usually is a 5th, but this just saves a little time. All right, so we're going to plug in that number into the equation, right? We're going to guess and check. We're going to take this 0, -2, we're going to plug it in. Don't forget, 0 is the x coordinate, -2 is the y coordinate. So when I plug in x, I plug in 0. When I plug in y, I plug in 2. Let's try the first equation, all right? Y equals x minus 2. When I plug in 0 for x, and I plug in -2 for y, my equation says that -2 equals -2. True. That means that is a solution to that equation. So we've check marked half of it. We've said, okay, so far I found 1. A works for the first equation. Let's check the second one. All right, 2y equals 8 minus 4x. We plug in -2 for y. Okay, don't get your x's and y's confused. Minus 4 times -2. Okay, 2 times -2, that's -4. 8 plus 8. Okay, don't forget a -4 times a -2 makes it +8. You can see that 8 plus 8 is not going to equal -4. So what that tells me is that 0, -2 is a solution to the first equation, but not a solution to the second equation. So I need to try a different one. So let's try the second solution. Let's try 2, 0. All right, so we're going to plug in 2, 0 into this equation here. All right, we're going to plug in 2 for x and 0 for y, right? We plugged in 2 for x and 0 for y. That makes this equation true, which tells me 2, 0 is also a solution to the first equation, but it has to be a solution to the second equation as well. So when I plug in 0 for y and 2 for x, 2 times 0 is 0, 8 minus 4 times 2 is 8, 8 minus 8 is 0. As you can see, it works for that one as well. So by using guess and check, we were able to solve this system of equations without really having to use any of the strategies that we learned about solving a system. So that's good that we're able to do that. Again, maybe this isn't the fastest way to do it. I think actually solving the system would have been the fastest way to do this, but that's okay. We're just practicing that strategy. All right, moving on. Now, let's actually go back and look at this first choice, okay? This first question, excuse me. There's actually a better way to do it than just going A, B, C, D, and E, than just checking those in order like that. There's actually a faster way, a more efficient way to do that, okay? So let's look at this, all right? First of all, in order to do this, your answer choices have to be listed from smallest to greatest. So you see how we've got small, and then it's increasing all the way to the greatest answer. Okay, that is part of the issue here. We have to have it in order, and a lot of the times on the ACT it is in order, so that's good. Okay, the second thing is that it has to, you have to be able to tell when you plug in a number whether it's too big or too small. Now, that's not always going to be the case, but if you can tell, oh, this answer is too big, I need to pick a smaller answer. If that's the case, then this strategy is going to be the fastest way to do it. All right, so let's take a look and give it a try. So here's a strategy. Don't pick A, okay? I want you to pick B first. That's your first guess, okay? I plug in B, I get 1 squared minus 3, that's 3 times 1. Divided by 1 is 1. I get that 1 minus 3 is negative 2 is equal to 1, so that's not a solution, okay? I determined that that's not a solution. Now here's the hard part here, is in this example, it's kind of hard to tell whether that number was too big or too small. But what I can do here is pick D next. Okay, so I'm gonna pick D next. So now I found out that B was not the answer. Now at this point, if I could tell that 1 was too big, then what does my answer have to be? Yeah, it has to be 0. If I can determine at this point that 1 is too big and 0 has to be the answer, that's why that strategy is efficient, because I can immediately tell, oh, the one below it's the answer. But in this case, I know that it is not too big, right? So that means A cannot also not be the answer. So we can actually eliminate 2 choices there. All right, so first thing you do is pick B. Second thing you do is pick D, okay? Now here's the thing. If D is correct, we got it. We only took 2 guesses to get there. If D is not the answer, then, and you can tell that it's too big, then what has to be the answer? That's right, it has to be C. If D is too big, you know it's C, because you know it wasn't B or A. Now what if D is not the answer, but it's too small? Again, then you're narrowing it down to E. So let's write that down. Let's write these things down, okay? So of your 5 choices here, A, B, C, D, and E, you always want to start with B, okay? This is your first guess, okay? Now, again, if it is B, and you guessed B, of course, you're going to know that. You're going to be like, okay, I got the right answer on the first guess. That's perfect. If B is too big, and again, this has to be in order. If B is too big, then you know it's A, okay? So if it's not too big, in other words, if it's too small, you've eliminated 2 choices with 1 guess, okay? Then the next, let's say you eliminate these 2 choices, then you pick D as your second guess. Okay, now again, if D is correct, you got it. It only took you 2 guesses to get there. What if D is too big? Then you know it's got to be C, because C is smaller. What if D is too small? Then you know it's got to be E. So this strategy works because it only takes 2 guesses to narrow it down to the correct answer, okay? Now, just as a reminder, it's got to be in order from smallest to largest, and it has to be a problem where when you plug in a number to guess, you're going to be able to tell whether it's too small. So it doesn't always work, but if you're going to use guess and check, you got to kind of think about this, because it really is a faster way than guessing up to 5 answers, which isn't very good. All right, moving on. Oh, one more thing, actually. So this will not work if they say something like, what is the largest value that works? Okay, if they say something like largest, well, it's supposed to be a G. What is the largest value that works? Okay, or maybe smallest value. But if they say what's the largest, it's not going to work this way, because if you find one that works, it doesn't mean it's necessarily the largest. You have to kind of keep trying all the other ones. So in that case, you might try doing it by hand, or this strategy could still work, but guess and check, that is, but you might have to try other things. This strategy might not be as efficient. All right, so let's look at guess and check with multiple answers, okay? Guess and check with multiple answers, and let's see what that looks like. So for example, let's say you're working a problem And it says for A, X is 2 and X is 3. So it's giving you multiple choices here. All right, maybe there's B. All right, C says that X is 4 and that X is negative, or excuse me, X is 3, X is 4, and X is 5. X is 1 and X is 6. So let's look at this. So each answer has multiple choices. So if we're going to guess and check, first of all, the strategy we just learned, that really efficient strategy of picking B first and then D, isn't going to work here because they're not really in order. It doesn't really make sense in this context. So what number do we want to guess with? Do we want to just start with A and work our way down? That's not a horrible idea, but really what we want to do is we want to pick numbers that are going to help us eliminate choices. So here's the thing on the ACT. A lot of the times they will, it's really doubtful. If you look at E, see how E is kind of all by itself, 1 and 6. There's nothing that matches there. It's really doubtful that that's going to be your answer. You want to stick to guessing things like X equals 4, because X equals 4 appears twice. So by guessing X equals 4, if X equals 4 works, then you've narrowed it down to 2. So you've eliminated 3 choices. If it doesn't work, you can get rid of those 2 choices. So you've eliminated 2 choices. If you guess X equals 1, chances are it's not going to be the one anyway, but you're only going to eliminate 1 choice. So good choices of numbers here. Let's think about this. We've got 2s. I see multiple 2s. So 2 would be a good number to test. I see several 3s. So 3 would be another good number to check. And then 4. 4 appears more than once. So the fact that I can eliminate many choices by guessing these numbers make these good guesses in my guess and check strategy. All right, very cool. Moving on. So another example of multiple choices, in other words, answers that have multiple values that work or solutions, is inequalities. Let's take a look at that. All right, so in inequalities, they have many solutions as well. So there's 2 types of answers we're going to look at. We're going to look at answers that are in graphical form. You'll see it shaded like that. So that's a graph form. And the second answer is just basically inequality form, where it's written using words and letters. So something like X is greater than 5. Okay, so we're going to look at these 2 things, the inequality form and the graphical form. Okay, the inequality and the graph. We're going to look at 2 different examples. So here's what you want to do. First of all, let's look at an example, okay? And I'm just going to give you the answer choices because really guess and check is all about just picking the answers. So let's say we have X is greater than 10, X is less than 10, X is greater than -6, X is less than -6, and X is less than -10. Okay, so maybe the problem was 2X is greater than X minus 6. Okay, and there's my answer choices. So don't forget inequalities have multiple solutions, right? Look at this graph up here where it says right underneath the word inequalities. You can see that each one of these points that I'm coloring in are solutions. Right? So there's many solutions here to that equation. So basically I can pick anything I want. Now looking at my answer choices, again, I want to choose numbers that will help me eliminate things, okay? So you see where it says X is greater than 10 or X is less than 10? Picking something to the left or to the right of 10 is gonna help me narrow that down. So that's always a good thing. If I can narrow it down, like that's a good thing to do, okay? So let's try guessing 5. Okay, 5 might be a good guess here. If I guess 5 and I plug that into my equation, I get 2 times X, which is 5, is greater than X, which is 5, minus 6. I get 10 is bigger than -1. That's definitely true, which tells me that 5 is a solution. So 5 should be in the solution set. So if I look here at choice A, it says X is greater than 10. That's saying all the solutions are bigger than 10, which we found out that 5 is a solution, so it wouldn't make sense that all the solutions are bigger than 10, because I just found an example where it's not. So I could say A is not true. Okay, B says X is less than 10. Yep, 5 is less than 10, so we're still holding on to B as a choice. I remember with guess and check, just because I found one that works doesn't mean I'm done. I have to kind of check the rest here. C says that X is greater than -6. 5 is greater than -6. So we're going to hold on to that one as well. D says that x is less than -6. 5 is not less, so we're going to cancel that one out. All right, on E, it says x is less than -10. Since 5 is not less than -10 and 5 is a solution, we're going to say that's not true. So now we're down to 2. So it's either less than 10 or it's bigger than -6. Okay? So this is kind of tricky because -6 is here and 10 is here on a number line. And one of them says that everything bigger than -6 is the solution. And one of them says that everything less than 10 is the solution. So what if I pick 0? Would that be a good choice? That would not be a good choice because it's going to be a solution to both. So it doesn't help me narrow down anything. What would be better would be something like 12. If 12 works, then I know that x less than 10 is not true. It's not our solution, but that x is greater than -6 would work. So I'm going to test 12 into the equation. So go back up here to the equation. I type in 2 times 12 is greater than 12 minus 6. That says that 24 is bigger than 6, which is true. So this is a solution, which means that x less than 10 doesn't work. Because not all the solutions are less than 10. I found one that's bigger than 10. That narrows it down to C. All right, again, we're just showing this guess and check strategy for inequalities. All right, moving on. Oh, one quick thing, don't forget, when you're doing this, you can pick solutions or non-solutions. For example, if you have a graph example, right, and this is maybe A, this is choice A, and choice B is kind of the same, except it's maybe all these things here. You could test a non-solution, like you could test 0 here. And if it doesn't work, then you'd say A is a possible solution, or a possible graph of the solution set. Because A shouldn't work, because see how A is not in the solution set, the shaded part? So you can also pick numbers that aren't solutions, and just make sure that when you plug it into the equation that it doesn't work, okay? It just has to make sense with the picture. If it doesn't make sense with the picture, then you know it's not the correct answer. All right, second strategy is called pick a number. So remember that guess and check strategy, mainly for equations and inequalities. This strategy is best for anytime you're dealing with like a fraction or a percentage problem, okay, that deals with an unknown amount. So for example, they always ask a question like this. You know, let's say John spends 1/5 of his money on rent. Then they're on the remaining money, okay, he spends 1/4 on gifts. And then with the remaining money, okay, it's important that you're talking about what's left over. On the remaining money, he spends 1/2 of it on whatever, food. Okay, so this kind of thing, it doesn't tell you how much you start with. Okay, so we're starting with an unknown amount, and we're going to work to where it doesn't matter what we start with. Okay, that's kind of the whole point of the strategy, that it doesn't matter what you start with. So let's try this here. Let's just pick a number. Okay, let's start with 100. Okay, that's usually a good starting place. And also the question is, what percent is remaining? Okay, it's important to know that. The question is, what percent is remaining? That's close to the word remaining. All right, so let's say we start with 100, okay? It doesn't actually matter what we start with. You can pick any number you want. But if he spends 1/5 of the money, how much would be left? Well, we got to know what 1/5 of 100 is, right? Pop out your calculator. 1/5 times 100, that gives you 20. So he spends 20, which means he has 80 left over, okay? That's after spending 1/5 of his money. Then he spends 1/4 of what's left over. So then we have to know what 1/4 of 80 is. So 1/4 of 80 is 20, okay? So he spends 20 more dollars. That leaves him with 60 bucks. Okay, that's after he spent 1/4 of his remaining money. Now he's got 60, now half, that's the easy one. That leaves $30 left. Now here's the cool part about this strategy. If you start with 100 and you're asked what percent is remaining, the cool part about starting with 100 is 30 is the percent. 30 is 30% of 100. Percent literally means per 100, so 30 out of 100, that's what percent means. So in this question, when you use 100 and you get down to 30, you don't have to do any other work. 30 is the percent. Okay, now let's say you have the same question, all right? 1/5 of his money, then 1/4 of his money, then 1/3 of his money, but the question says, what fraction is left over? Okay, this case, it doesn't matter what you start with. Again, you don't have to start with 100. What you do want to make sure that you do is, especially if you're trying to do this in your head, is see these denominators. You need to pick a number that is a multiple of these denominators, okay? Something that is a multiple of 5 and 4 and 3. Easy way to do that, what's 5 times 4 times 3? 5 times 4 is 20, times 3 is 60. 60 is a great number to start with here, because when I do 1/5 of it, it's going to come out to be an easy number. If I did 62, 1/5 of 62 is a much more complicated problem. And if you have your calculator, you can still do it. But here's how it works. 60, okay? You're going to take away 1/5. So first you got to count what is 1/5 of 60. So break it into 5 equal parts, take 1, that's 12. So take away 12 gives you 48, okay? Then you take 1/4 of that. So 1/4 of 48 is 12. So you take another 12, that leaves you with 36. Then you take half, or excuse me, 1/3 in this case. I changed the problem on myself. 1/3 is also 12. So oddly enough, you get 24. Now the question says, what fraction is left? Well, fraction is always part over the whole. So what part do I have? Well, I have 24. That's the part that's remaining over the original part, the whole, which is 60. So that's your answer. Now you won't see 24/60th on the test because you'll have to reduce that. And there's ways to do that on your calculator. Just hit the fraction button under math. But that reduces to, let's see, they're both multiples of 4. That is 6/15. Those are both multiples of 3. So 2/5. Okay? Easy way to do that problem. So just pick a number to start with, because it doesn't really matter what you start with. If I started with, let's say we start with 120. Okay? 1/5 of 120 is 24, so that leaves us with 96. Then 1/4 of that would be 24, so that leaves us with 72. 1/3 of that is 24, so that leaves us with 48. If I looked at the fraction 48 out of 120, right, what fraction is left? That's going to still reduce to 2/5. So it doesn't matter what you start with. Okay, so this strategy is called pick a number. Especially though, if you're doing percentage problems, pick 100 to start with. Really, really important. If you're doing fractions, doesn't really matter. And that's all I got for that. All right, moving on. All right, so now we're going to talk about the 2 main strategies for the day. These 2 are the big ones. Those other ones are really good. These 2 are really, really powerful, especially the first one. It is one of the most important things you can do to raise your ACT score in the math section. So let's look at this. Before we do, I just want to kind of look at something real quick, okay? I want to compare these 2 things here. Okay? Just want to compare these 2 things. Now, first of all, 2x, equation or expression? Obviously, an expression, there's no equal sign, there's no left and right side. So that's pretty easy to do. Let's look at what happens when I evaluate. Remember, evaluate means value, value means number. So when I plug in the value of x, I get something back, okay? So let's first look at what happens when I plug in x equals 0. Okay, plug it into 2x. 2 times x. Well, if x is 0, that means 2 times 0. And 2 times 0 is just 0. Okay, so the value of 2x is 0 if x was equal to 0. Okay, now let's look at 4x divided by 2, a totally different expression. okay? 4 times a number divided by 2. Now, what if x is 0 here? Let's evaluate that. 4 times 0 is still 0, and then 0 divided by 2 is 0, okay? So the value of that expression is also 0. All right, let's look at a different number. Let's let x equal 1, okay? Let's look at the first expression, 2x. When x is equal to 1, 2 times x, since x is 1, 2 times 1 is 2, okay? Let's look at 4x divided by 2. 4 times x when x is 1. So 4 times 1 is 4, and that divided by 2 is 2, okay? What about x equals 2? 2 times 2, now we're letting x equal 2. 2 times 2 is just 4. And in the second expression, 4 times 2 is 8. And 8 divided by 2 is still 4. That's interesting. This is kind of playing out weird. Let's try something interesting here, like 7.2, something weird. Okay? 2 times 7.2, that's 14.4. All right, what's 4 times 7.2? That's 28.8. Okay, you can use your calculator to check that. Divide that by 2, 28.8 divided by 2 is 14.4. So what do you notice about these two things? No matter what x is, okay, we always get the same thing. For every x, for any x I could pick here, these things will be the same value. Okay, that is the key to this next strategy, okay, is understanding that really 4x divided by 2 is the same thing as 2x. Okay, so this strategy is going to help us simplify expressions. We're going to cheat a little bit, but we're going to be able to simplify any expression using this technique. Now don't forget, to simplify means to rewrite in a different way that really is the same. We say equivalent in math, okay? That means they're equal. Two things are equal, but they look different. That's what simplifying is, okay? Simplifying means to make it equal, but look different. For example, if I said simplify 4x divided by 2, you would say, oh, well, I can cancel. I can rewrite the 4 as 2 times 2 times x. Okay, I can rewrite that as 2 times 2 times x, and then I cancel one of the 2's. That leaves me with 2x. That's our example from earlier. 4x divided by 2 simplifies to be 2x. They're the same thing. And we tested that. We plugged in different x values, and we found out that they're the same under any condition. No matter what x is, 4x divided by 2 will be the same thing as 2x. So that means it simplifies to be. Okay, so here's the strategy. Okay, the strategy to doing this, remember this works for expressions only. Okay, this works for expressions. The strategy is to pick numbers. Okay, you can kind of pick anything you want. You're going to pick a number and you're going to test the number. Now, where do you test the number? Well, you test it into the original expression, right? In other words, the question. And then also, you're going to test it into each answer. Okay? That's how the strategy works. Now, if you test the question, right, what they give you at the beginning, all right, you get a value for that expression under like whatever when x is equal to 2, okay? And then you test each of the answers. What you're looking for is a match, right? It has to be the same. So if it matches, if the answer matches the original expression, then it is a possible answer, okay? If it matches, it's a possible answer. If it doesn't match in any way, if it's negative or one off or a little bit different, if it doesn't match, that tells me that it is not a possible solution, okay? You test that answer. If it doesn't match, it's not even possible. If it matches, it's possible. Now, if it matches, it doesn't mean it is the answer. It just means it's possible. So you have to test all 5 in this, and we'll see some ways to make this more efficient. But that's kind of the idea. All right, now there's 2 methods here, and this is a preference, okay? I want you to pick whichever method you feel most comfortable with, okay? But let's look at method 1. Method 1, it's very methodical. You do it the same way every time. You pick 0, then you pick 1, then you pick 2, okay? Almost every time in that order, okay? You're gonna test with 0. You're gonna see what happens when you test it with 0, all right? You're gonna eliminate choices that don't match. Then you're gonna test it with 1. You're gonna eliminate choices that don't match. Then the last time, if you need to, sometimes you don't, but sometimes you have to, you test it with 2, and that will ultimately give you your answer. Now, for some reason 2 doesn't work, try 3, but I've never seen it not work. Usually 0, 1, and 2 are enough. Now, here's some pros, some reasons why this is a good method, all right? It's easy to do in your head, okay? You can do x squared, you can do something crazy like x squared minus 3x plus 10 in your head with x equals 0. That's 10. See how fast I did that? 0 squared is 0. Minus 3 times 0, that's 0. 0 minus 0 plus 10 is 10. Things like polynomials that look like this are really quick to do in your head. So the pro is it's easy to do in your head. All right, you can do it in your head. Even 1. I can look at this and tell you that this is going to be 8. 1 squared is 1. Minus 3 times 1 is negative 3. 1 minus 3 is negative 2. Negative 2 plus 10 is 8. Okay? These are easy to do in your head. Now the cons. Here's a reason you might not like this method. Okay? You might have to try 2 or 3 different numbers. Now, for some people, that's a lot. When I say 2 or 3 numbers, I'm talking about you might have to test 0 with 5 different answer choices. And then you might have to go back and test 1 with 5 different answer choices. And then again, you might have to go back and test 2. Now, hopefully, things start getting eliminated so you don't have to test 5 every time. But that's very possible. It could take a little bit of time this way. But again, I would choose this way if you're good with like algebra in your head. If you're good with algebra, I would pick method 1 because I'm pretty good with algebra and I can do this pretty quickly. So if you're pretty quick with algebra, this might be a good method to choose. All right, method 2. All right, the strategy here is that you pick a weird number. I like 9. It's really close to all the operations on the calculator. 9 is really close, so it's just like really fast. Pick something weird like 9. It doesn't have to be 9. It can be anything else. Okay, but pick kind of a different number, a bigger number. Here's the pros, okay? You only have to test it once. It's possible you might have to test 2 different numbers. It's possible that 9 could work with multiple equations, but the chances of it are very slim. So usually you only have to do this thing 1 time, okay? The con is you can't do it in your head. You have to kind of use your calculator or do it by hand. I would use my calculator. I'm a little faster with my calculator. So that's the only problem. So if you're good with your calculator, this might be the way to go. This can be super fast. So what I would do is I would take that like up here where I have x squared minus 3x plus 10. I'd go 9 squared minus 3 times 9 plus 10 in my calculator, see what it is, and then start testing that into all my answer choices. So almost guaranteed you only have to go through each choice 1 time. So it can be pretty fast. So again, that's up to you. If you're good at algebra, maybe choose method 1. If you're better with your calculator, maybe choose method 2. It's just kind of a preference thing, okay? All right, so before we get started, I just want to go over real quickly how to do this fast. All right, so something like this, 3x to the third minus 7x to the fourth minus 10x, okay? This is called a polynomial, and I know it's out of order. Let's make it 13th so it's in standard form. It goes from largest power down. Let's try to evaluate this thing when x is 0, okay? What's the answer going to be? What is 3 times 0 to the 13th minus 7 times 0 to the 4th minus 10 to the 0? It's 0, right? Think about it. What is 0 to the 13th power? It's still 0. If you multiply it by 3, it's still 0. So you get 0 there. Minus 7 times 0 to the 4th. Well, 0 to the 4th is just 0. If you multiply it by 7, you still get 0. Basically, anything with an x in it, see how there's an x and an x and an x? When you plug in x equals 0, those are all going to 0. Okay? Now, what if this said plus 7 at the end? Then, of course, yeah, it wouldn't go away because it doesn't have an x, so your answer would be 7. Okay? Pretty quick, though. All right? Let's try a different number here. Let's try x equals 1. Now, this is just as fast, a little bit slower, but it's just about as fast, okay? So what is 3 times 1 to the 13th power? Well, 1 times 1 times 1 times 1 times 1. That's just 1. Times 3 makes 3. So we just get this number right here, okay? Minus 7 times 1 times 1 times 1, 4 times. Well, 1 to the 4th power is 1. Times 7 is 7. So it's just 3 minus 7. You just get this thing right here. What's this going to be? It's going to be minus 10. What's this going to be? Plus 7. There's no x to affect it. So see how basically when you're dealing with polynomials that you just look at what we call the coefficients. It's a fancy name for the word, or excuse me, fancy word for the number in front, okay? So then all you got to do is figure out that. It's pretty quick. 3 minus 7, negative 4. Minus 10, negative 14. Plus 7, negative 7. So I can figure out the value of these things pretty quickly, especially with 0 and 1. 2, nah, that's a different story. I would definitely break out my calculator for x equals 2. I would not try to evaluate this in my head because that's going to be true. All right, there's a little background knowledge for you. Okay, so let's try an example of this strategy. All right, 3x times 4x in parentheses squared. All right, so what is 3x times 4x squared? Well, a couple ways to do this. We're going to try our testing strategy though, okay? This is an expression, not an equation, so we're going to use our expression strategy. All right, let's look at our answer choices first. We get 12x squared, 12x cubed, 24x to the third, 48x squared, and 48x cubed. All right, so remember what we're going to do is we're going to say, okay, let's let x equal 0. What is this top expression worth when x is equal to 0? 3 times 0 is 0, times 4 times 0 is 0, squared is all 0, 0 times 0, it's just 0. So that's our target number. Now let's plug this into all of our 5 choices. 12 times 0 squared, that's still 0. So A is still a possible choice. We're not gonna dismiss it. All right, 12 times 0 cubed, looking at B. Well, 0 cubed is 0 times 12, that's still 0. So it's a possible answer because it matches what we got over here. All right, sorry, that might be out of frame. 0 is what we're looking for here. That's our target value. If I look at all these, see how they all have an x attached? They're all going to be 0. So that actually doesn't help me eliminate anything. 0 didn't help me. Let's go back and try x equals 1. All right, now we go back through and try x equals 1. Well, what is this thing worth when x equals 1? 3 times 1 is 3, times 4 times 1 is 4. 4 squared is 16, right? I'm just evaluating here. 4 times 1 is 4. 4 squared is 16. 3 times 1 is 3. 3 times 16 is 48. So what is a when x is equal to 1? It's just 12. 12 times 1 squared is 12. So it can't be a, right? I've eliminated the choice A because 12 times 1 is not 48. It has to be 48. That's what this thing up here was worth. Everything that matches is possible. So if it's not 48, I can eliminate it. I can easily see B isn't going to work because 12 times 1 cubed is 12. Can't be C because 24 times 1 cubed is 24. It's either D or E. Okay, so I've narrowed it down to 2. Now, let's go back through. Let's do one more. Let's try x is equal to 2. So what is the expression on the top here when x is 2? Well, it's 3 times 2, which is 6, times 4 times 2, which is 8 squared. So times 8 squared. Now you might break out your calculator for this one, okay? 8 squared is 64. 64 times 6 is 384. Okay, so that's our target value, 384. If you plug it in here, you'll see that 48 times 4, which is what we get when we get 2 squared. 48 times 4 is not going to be our answer. What we want is E, because 48 times 2 cubed is going to be 384. So this strategy helped me if I didn't know how to work the problem. Now this problem is much, much faster if you do it the way you're supposed to do it. Remember, this is a backup strategy, but it works every time you have an expression. You can just pick values for the variables and work it. All right. All right, let's look at another example here. X squared minus 6x plus 8. Okay, we're supposed to simplify this. And we have some choices here. X minus 4 times x minus 2, x plus 4 times x minus 2, x minus 4 times x plus 2, x plus 1 times x plus 1. Now there's supposed to be a fifth choice, but just to save time, I'm not going to mess with it. All right, let's do this real quick. X equals 0. What is this thing worth when x equals 0? It's going to be 8. Okay, now take a second to make sure you understand that. 0 squared minus 6 times 0 plus 8 is just 8. These are really quick to do when you're dealing with 0. Now over here, it's a little more complicated, all right? I got to plug in 0 for x. So I get 0 minus 4, which is negative 4, times 0 minus 2. 0 minus 2 is negative 2. So negative 4 times negative 2 does give me 8. So A is a possible answer. It's not the answer necessarily. It's a possible answer. Let's try B. When I plug in B, when I plug in 0 for x in B, I get 0 plus 4, which is 4, times 0 minus 2, which is negative 2. 4 times negative 2 is negative 8, which does not match what I got with the original. So I can say that B is not the answer. All right, C, 0 minus 4 is negative 4. 0 plus 2 is 2. That's going to be negative 8 again, so it's not C. It's not matching what my original was. And on the bottom, pretty quick to tell, 0 plus 1 is 1. 0 plus 1 is 1. 1 times 1 is 1, which does not equal what I'm targeting there, which is this 8. So the only thing that gives me 8 was A. Therefore, A is my answer that's correct. Now remember, factoring this would be the best way to do this. It's much faster, but if you ever get stuck on a problem you don't know how to do, this is a great way to wiggle your way into getting the correct answer. Okay? All right, let's look at one more example. All right, we're supposed to simplify 2xy squared minus 6x to the fourth. And we've got some choices here. 2x times xy squared minus 3x to the fourth. And B, 2x times y squared minus 3x to the third. I'm only going to do 2 here just to save a little time. Now notice, what's different about this one is that there's 2 variables now. There's an x and a y. So you have to pick an x and you have to pick a y. Now a couple things. 0, 0 is usually one that won't, it's fast, right? If you let x equal 0 and y equals 0, it's super fast to figure what this thing is. But it usually doesn't narrow down as much. So I recommend things like x equals 1, y equals 0, and then maybe as my second choice, y equals 1 and x equals 0, where I switch them up. Okay, let's try that with this. So what is the value of this expression when x is equal to 1 and y is equal to 0? Well, when x is 1 and y is 0, if y is 0 here, we're multiplying by y squared, 2x times y squared. Well, that's going to be 0 because the y squared is going to be 0 and 2x times 0 is 0. And since x is 1, this thing is going to be negative 6. So we get negative 6 in our first case. So one of these should be negative 6. So when x is 0, when x is 1, I get 2 times. When y is 0, remember this is 0. So 0 minus 3. 2 times negative 3 is negative 6. So this one is a possible choice. Let's try this one. 2 times 1 is 2. Y squared is 0 minus, I get 3, I get negative 6 again. So that didn't help me narrow it down any. We could try the other one, but I can tell pretty quickly that this is still going to be one that gives us the same. So then I have to try a third one. Let's try x equals 2 and y equals 0. Okay, if I try this one, I'm not going to go through it, but this strategy will actually lead me to the answer choice B. It's the only one that matches. But again, I'm just showing you an example of what to do with multiple variables. So when you have multiple variables, maybe let one of the variables equal 0 and the other one equal 2. That's a good starting point, or 1. Again, there's no right way to do this strategy. It's just you got to practice it so that you can get fast at it. Now, if you did choose something like this, if you choose x equals 4, y equals 6, those are weird enough numbers that that's probably the only one you'll have to test. So maybe if it's multi-variable, you go with method 2, where you pick a weird number. Okay, weird numbers like 4 and 6. The only one that's going to match is going to be the correct answer. The other ones won't quite match up. All right? All right. Moving along. That was the end of that strategy. Now, that's the best strategy I can teach you. That thing right there can come in and save you in any problem where you don't know how to do it, but you're solving an expression. If you're solving an expression and you don't know how to do it, that strategy is going to help you for sure. All right, next one. We're going to learn how to solve an equation with our calculator. All right, so here's the idea, right? An equation, we talked about it in week 1, is just a left side equal to a right side, 2 equal expressions. When you have a left side equal to a right side, you've got an equation. So what we're going to do here, here's the steps. You're going to graph the left side. Now, when I say that, you're going to type into y equals in your calculator, and you're going to type in whatever the left side says. Okay, if it's a whole bunch of stuff, you just write all the stuff. Okay, secondly, you're going to graph the right side. And again, you're going to say y equals whatever the right side says. So whatever's here goes here, whatever's here goes here. Okay, third step, you're going to find the intersection point. Now I'm going to put a little parentheses S there because it could be more than one point. Those things might cross in 2 different locations. It's possible you're dealing with things where they cross. But wherever they cross is going to be the solution. Now, a couple things here, right? We're dealing with an equation that has just x's in it. Okay, I mean, maybe it could be a different letter, but only one variable. This is what we're going to be able to do is if it's only in one variable. If there's 2 variables, we can't do it this way. But what you're going to get is this intersection point. Now, there's going to be an x coordinate and a y coordinate, right? This location is an x and a y. We don't care about the y. All we care about is the x number. The x number is what matters to us. Okay? This x here and this x here, whatever the x, y coordinate is, we don't care about the y. We just care about the x. These are going to be my solutions to the equation. Okay? Now, a couple things, and you'll see I've got a calculator on here that I can show you. But you may need to adjust your window because when you graph these things, it may not be where you can see the intersection, and your calculator can't do it unless you can see where the 2 things cross. So there's a couple strategies there that we can work with, but you've got to make sure you can adjust your window. So that's something you might have to practice, and I'll make sure I put that in week 1 is kind of how to use your calculator as far as the window goes. Okay, making sure you can adjust the window on your calculator. All right, so here we go. All right, so let's look at this example here. All right. All right, so let's look at our first example here. We're going to solve this equation, 3x squared minus x minus 4 is equal to 0, okay? We've got our left side here and our right side here. So I'm going to break now and go over to the calculator, but write this down, okay? So you're going to be able to solve this using your calculator. I want you to write this, go ahead and write this down. All right, so here we are. We've got a graphing calculator. As you can see on the left here, this is kind of a picture of what your graphing calculator would be. And this big screen in the middle here, that represents what you would actually see on your screen. Okay, now over here to the right, it kind of is cool, but it will display the equation, the graph, and the table, which are three very intertwined things all at the same time, so you can kind of see that. But we're going to focus mostly on what you just see on the screen. So remember with this strategy, we're going to graph the left side and we're going to graph the right side. So I go to y equals, go ahead and clear out whatever's here, okay? Graph the left side. So the left side of that equation says 3x squared minus x minus 4. All right, so you can see as I'm hitting those buttons, it's popping up on the screen. That's the left side of my equation. If I hit down, I can get down to the second line. I'm going to graph the right side. Now, the right side has a 0. That's all it has, okay, and that's okay. Now, if I go up here to graph, I can click the graph button, and you'll see my two graphs. Okay, so what I said was that we have to find the intersection point. That is the solution to this equation that we had originally. So all I got to do is find the intersection points. Now, you can kind of see here, I think you should be able to see my cursor, because that looks like it's -1. I mean, I'm pretty sure that's a -1. I'm 94% sure that's a negative. Over here, looks like 1 and a little less than a half, maybe 1 1/3, but I'm not 100% sure. Now, if you look at the test and you see -1 and 1 1/3, go for it. I mean, that's what it is, right? We just I want to show you how to find it specifically. Maybe it's like an answer where it's 7/5, right? 7/5 is not something I'm going to be able to look at and go, oh yeah, that's probably 7/5. So let's figure out how to do that. All right, so first off, under the trace button here in blue, you'll see the word calc. That's for calculation. We want to do a calculation here. So I have to hit second to get to the calculation function. So second trace, that gets me to the calculate button. We want to find the intersection point. So number 5, you can go down, boom, 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 or you just hit the number 5, it'll take you directly there. Now this is a dumb question, first curve, second curve, but you just have to go through it. It's part of the calculator software. It's asking which of these curves would you like to be your first curve? And as you can see, y1 is this x, it's the blue one, right? We're just going to hit enter. If you don't have more than 2 graphs graphed, which we don't, if we go back to y equals, see how I only have y1 and y2? It's kind of a dumb question. But anyway, I just hit enter to select this as my first one. Then it says, which one would you like as your second equation? Oops, I guess I've got that. Back here we go. First curve, yes. Second curve, yes. You want to select the next one. Now, guess. This is where you have to kind of get close. So use your left or right buttons to get this little, I call it a spider. Get it over to where you think it's as close to that as you can, that intersection point. And hit enter, and there we go. Now remember, I do not care about the y number. I just care about the x number. So my first solution to this equation is -1. Now, let's go through that process again. I want to find that other intersection point, that positive one. So I go to second. Actually, I'm going to allow you to see my history here so that you can make sure you understand it if I'm going too fast. All right, so here's my history. Second, calculate. That's trace, right? That's why it says trace calculate. Number 5. And then first curve, yes, so I hit enter. Second curve, yes, I hit enter, and then guess. So now I have to actually scoot over. I have to hit this a few times till I get over close to where I guess that my intersection point would be, somewhere around there. I hit enter. Now it says 1.33333333. Chances are you will not see 1.33333 on the test. Chances are you'll see a fraction. So how do you do that? Well, first off, get out of graphing mode, okay? Second mode, right here where it says quit. Second mode. That gets you back here. And just type in 1.333. Now you got to make sure you type enough 3s to get you to the end here. Okay, make sure you got enough 3s. I always hit enter. It pops up with however many 3s it holds. Okay, then you go over here to math. You hit math and then into frac. That's what we want, into fraction. Hit enter. It'll take that answer and it will convert it into a fraction, 4/3. All right, and that's basically the strategy. This thing works for any equation possible. Any equation where there's a left side and a right side and there's only one variable, you can use this strategy. So I'll work another example here, but I want you to know that this is basically, it's all you need as far as solving anything. We'll work one more example here though. All right, so let's try a different one. Let's try a more complicated equation. This time we'll do like a rational function. So maybe we have 3 over x equals 7 minus x over 4. Okay. Now, first of all, I can write a fraction here by doing alpha y equals. Let me get this history cleared out. This is kind of ugly. All right, alpha y equals will get me to this fraction menu here. All right, I choose number 1. What that's going to do is make an actual vertical fraction, something that you can see as an actual fraction instead of like the divide bar, which doesn't look very good. It doesn't look like anything you'll see. So let's try this. The left side says 3 over x. All right, that's the left side of the equation. We go down here, we type in the right side, it's going to say another fraction, so alpha y equals number 1, and we're going to do 7 minus x on top. We're going to have a 4 on the bottom. All right, so your equation would be something like 3 over x equals 7 minus x over 4. That's the equation. So we graph the left side, we graph the right side, we find the intersection point. All right, now we hit graph. There we go. Now it's kind of crazy looking, but you can see they cross right about here. It looks like 3. All right, now here's a tip. You don't have to always go through this second, calculate, number 5, blah, 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 blah. You could just look at the table, especially if you look at the answer key on the ACT and you see a bunch of whole numbers, it's going to be on the table. Let's try it. Let's try second graph. Okay, that's the table. The second graph, that's the table. We're looking for the y's to be the same. Now look at 3. When x is 3, the left side is 1, the right side is 1. That means that's a solution. Also look at number 4 here. 3/4 and 3/4. There's 2 solutions here. And I looked at that from my graph. Because remember what we're doing when we say a solution is it's a number that when I plug in, the left side equals the right side. So this number 3, when I plug it into the left side, I get 1. When I plug it into the right side, I get 1. That means it's a solution. So one thing you can do is look at the table. Now let's say you're not really super comfortable with that. Let's go back to the graph, okay? Second, calculate. Number 5, the intersection. Enter, right? First curve, second curve. Oh, now here, the first curve, this is a good thing to point out. Right now, it's trying to find the first curve, okay? Now see how it says x equals 0? X equals 0 is not defined on the function. There's no place vertically on x equals 0 where this blue line exists. So I actually have to scoot over before it'll even allow me to hit enter. I keep hitting enter, nothing happens. I'm hitting enter right now, nothing. So I have to hit over. Now, if you want, you can kind of bring it into position where you can see it, but now I can see it. Okay, so I hit enter now. The second one is already in place. I can see the thing, so I hit enter. And then it says guess. And this is where I have to kind of get over here. Boom, I hit enter. Now, the problem with this is that other one is hard to see. It's hard to see that 4 is a solution, but if I go through these steps again, second calculate, number 5, first curve, second curve, and then move over for the guess, close to 4, you'll see that x equals 4. Again, I don't care about the y, I just care about the x in this strategy. All right, so this is the strategy to solving any equations. Graph the left side, graph the right side, find the intersection point either on the table or using that second calculate function, number 5. All right, last thing I'm going to talk about today is what's called a hidden answer, okay? It's something you probably could figure out, but I just want to make sure that you have it. So let's say you're working a problem and you get square root of 60 as your answer. Okay, you're working a problem, maybe it's the quadratic formula, you get square root of 60. So you're looking at your answer sheet and you see 3 square roots of 5, you see 2 square roots of 15, see all these things, right? But you do not see square root of 60. All right, what's the deal? So the deal is, you're supposed to reduce this. You're supposed to simplify. Now remember, simplify just means to rewrite it in a way that looks different, but really means the same thing. So this is the same as one of these 5 or these 4 choices, okay? So the goal is, how do I figure out which one is the same? Well, just type this into your calculator, okay? Convert into a decimal. Decimal is the thing that connects all things, right? You can rewrite square roots as decimals, okay? You can rewrite fractions as decimals. You can rewrite anything you want as a decimal, right? Mixed numbers, mixed fractions, whatever. even whole numbers, you can write them as decimals. So basically what I'm saying is if you get an answer and you're pretty sure it's right and you don't see it, convert it into a decimal on your calculator. Okay. The same way I did fraction, where I did math, and then I go to into frac, right? I hit the math button on the left of the calculator and I do into frac. That's how I make it turn into a fraction. How do I make it turn into a decimal? Same thing, hit math, and then the one with the arrow and it says deci. Okay, that will convert it into a decimal. That's all I got. All right, good job on week 2. We'll see you next week.